Problems on uniform plane waves. In a perfect dielectric, E bar zt is equal to 10 raised to 3 sine of omega t minus beta z volt per meter, ay bar volt per meter. Then calculate h bar of zt. So we write here the given E bar is E bar z comma t is 10 raised to 3 sine omega t minus beta z a y bar. This is equation 1. That means it is positive, it is in the positive y direction. So assume that wave is propagating in the positive z direction. We write here, that is here a y bar is given, so that is it is in positive y direction. Now assume wave is propagating in positive z direction. So the direction of E bar cross H bar is along positive z direction. Since E bar and H bar are mutually perpendicular to each other, H bar should be in the x direction. So we'll decide H bar is in positive x direction or it is in positive y direction. So we want E bar cross H bar is in positive z direction. A z bar, E bar is in positive y direction, that is a y bar, that is H bar should be in negative x direction, that is minus a x bar, because in this case a y bar cross a x bar minus a x bar is a z bar. Now E bar and H bar are related as E bar by H bar is equal to mu 0 by epsilon 0, that is 377 ohm. Therefore H bar is equal to E bar by 377 . So h bar is equal to 2.6525 sine of omega t minus beta z a x bar. Second problem, an electromagnetic wave propagates in a free space its fields are given as follows. V bar is equal to 30 pi e raised to j 10 raised to 8 t plus beta z a x bar volt per meter. H bar is equal to h0 e raised to j 10 raised to 8 t plus beta x a y bar ampere per meter. Find h0 and beta. Now calculation. First step is calculation of beta. First step is calculation of beta. So the given equation of E bar is equal to 30 pi e raised to j 10 raised to 8 t plus beta z ax bar volt per meter. This is equation 1. Next is standard equation of E bar. Is E bar is equal to E0 e raised to j omega t plus beta z ax bar volt per meter. This is equation 2. Now compare equation 1 and 2. So E0 is equal to 30 pi and omega is equal to 10 raised to 8. Now the velocity of propagation for the plane wave is omega by beta. Therefore beta is equal to omega by v. This is equation 3. Now what is beta? Beta is phase shift. Omega is angular frequency, that is 10 raised to 8 radian per second. V is what? Velocity of propagation. That is C for free space. For free space, velocity of propagation is denoted by V. That is, its value is 3 into 10 raised to 8 meter per second. Now put these values in equation 3. So beta is equal to 10 raised to 8 divided by 3 into 10 raised to 8 radian per meter. Therefore, beta is equal to 0. radian per meter. Next part is calculation of H0. Now we know that intrinsic impedance is given by equation for intrinsic impedance. It is equal to E by H, that is E0 by H0. For free space, it is equal to square root of mu 0 by epsilon 0, that is 377 ohm. So E0 by H0 is equal to 377. So H0 is equal to E0 by 377. Now what is E0? It is 30 pi. Therefore H0 is equal to 30 pi divided by 377. So H0 value is 0.25 ampere per meter. Next problem, next problem is same as that of the second, that is the calculations in the previous problem we have to repeat. If here the medium of propagation is changed, that is here we write repeat the calculations in previous problem, given data previous problem. If now the medium of propagation is changed, epsilon r is equal to 16. All other values are same, only the medium of propagation is epsilon r. So first is calculation of beta. So beta means phase shift. So the phase shift is given by beta is equal to omega by v. This is equation 1. Now what is omega? It is angular frequency. It is angular frequency, which is 10 raised to 8 radian per second. Now what is v? V is velocity of propagation. Which is equal to 1 by square root of mu epsilon. Now here mu is equal to mu 0, that is 4 pi into 10 raised to minus 7, and epsilon is equal to epsilon 0 epsilon r, that is 8.85 into 10 raised to minus 12 into 16. Epsilon r is 16, which is given in the problem. So v is equal to 1 by square root of mu is 4 pi into 10 raised to minus 7 into 8.85 into 10 raised to minus 12 into 16. So this answer is 0.75 into 10 raised to 8 meter per second. This is the velocity of propagation. So by using this value we can find the beta. 10 raised to 8 by 0.75 into 10 raised to 8. So it is 1.33 radian per meter. This is the phase shift beta. Next is second part is calculation of H0. Now we have this formula, therefore where E0 is equal to 30 pi and it is equal to mu by epsilon. Now mu is equal to, we know mu 0, 4 pi into 10 raised to minus 7, and epsilon 0, epsilon r is equal to 8.85 into 10 raised to minus 12 into 16. So it is equal to 4 pi into 10 raised to minus 7 divided by 8.85 into 10 raised to minus 12 into 16. So this value is 94.2 ohm. Therefore H0 is equal to 30 pi by 94.2. Its value is 1.0005 ampere per meter. Next problem. A 100 volt per meter plane wave of 300 megahertz frequency travel in the plus z direction in an infinite lossless medium with epsilon r is 9, mu r is 1, sigma is 0. Then write the complete time domain expression for E bar and H bar and calculate average power density of the wave. So first step, calculate the beta using equation of beta. So first we have standard equation of E bar is E bar is equal to E0 e raised to j omega t e raised to j beta z a x bar. This is equation 1. Now here given data. What is given data? E0 is equal to 100 volt per meter, F is 300 megahertz, epsilon r is 9, mu r is 1 and sigma is 0. Now the unknown term in the equation 1 is beta, phase shift. So we have to find beta. Beta is equal to omega into mu epsilon. This is equation 2. Now what is omega? It is angular frequency. That is 2 pi f. So it is 2 pi f is 300 megahertz. So it is 10 raised to 6 radian per second. What is mu? Mu is permeability. That is mu 0, mu r. So it is 4 pi into 10 raised to minus 7, 1. And what is epsilon? It is permittivity. It is epsilon 0, epsilon r. That is 8.85 into 10 raised to minus 12 into 9. Put this value in equation 2. Put these values in equation 2. So beta is equal to 2 pi into 300 into 10 raised to 6 into square root of 4 pi into 10 raised to minus 7 into 0.85 into 10 raised to minus 12 into 9. So answer of the beta is 18.86 radian. Now step 2. Now what is step 2? Put the values, put the corresponding values in equation 1. So equation 1 becomes 100 e raised to j 2 pi 300 into 10 raised to 6 t e raised to j 18.86 z a x bar. So we can write this equation as E bar is equal to 100 e raised to j 18.85 into 10 raised to 6 t to e raised to j 18.86 z a x bar. This is equation 3. Next is step 3. step 3. Now E bar is in positive y direction. We write here E bar is in positive x direction. Now the wave is traveling in positive z direction, that is E bar cross H bar is in positive z direction AZ bar. So H bar should be in positive y direction, that is AY bar. Now because according to cross product of unit vector AX bar cross AY bar is equal to AZ bar. Now E bar and H bar are related as it is equal to E bar by H bar. So H bar is equal to, this is equation 4. Now it is intrinsic impedance, which is equal to square root of E mu by epsilon. So it is equal to mu 0 mu r divided by epsilon 0 epsilon r. Now substitute the values. 4 pi into 10 raised to minus 7, 8.85 into 10 raised to minus 12 into 9, so it is 125.6 ohm. This is equation 5. Now put equation 3 and 5 in equation 4. So it becomes H bar is equal to 100 by 125.6 e raised to j 18.85 e raised to j 18.86 z a y bar. So we solve this equation and it is 0.796 e raised to j 18.85 into to 60 to e raised to j 18.86 z a y bar. This is equation 6. Next is step 4. Step 4 is average power density. Average power density of the wave is given by power average is equal to 1 by 2 R E E bar cross H bar. This is equation 7. Now here RE, what is RE? It is real part. So using equation 3 and 6 we get power average is equal to 1 by 2 into 100 into 1.796 AZ bar. So this value is 39.8 AZ bar. Power is in watt per square. This is the answer.